Learn EMC squared in 15 minutes. Well, hello everyone. How are you today? Welcome back to Easy Peasy Physics. Make physics easy and fun with me, teacher Aini. I hope all of you are in a pink while watching this video. Today, I am very excited to share with you the relationship between energy release during nuclear reaction and mass defect, or it is known as EMC squared. Before I proceed, the video contents includes first, introduction, followed by learning outcome, recall session, AMU, mass defect and energy, some evaluations, and we end with conclusion. My dear students, have you ever heard of the atomic bombing of Hiroshima and Nagasaki at Japan? If yes, do you ever know the recipe in the successful of the creation of this atomic bomb? Yes, you are right. The secret recipe of the atomic bomb is EMC squared. Before we proceed, we need to know what we should expect at the end of this video. At the end of this lesson, students should be able to describe relationship between energy released during nuclear reaction and mass defect, which is E equal to mc squared. Alright students, let's go to the recall session. Let's recap a few things. In the last lesson, we have learned about nuclear reactions, which are nuclear fission and nuclear fusion. Let's recap on nuclear fission today with me. So, do you still remember nuclear fission produced a very massive amount of energy? Here is the equation of nuclear fission. So students, let's watch this short video on how nuclear fission happens. Alright, let me play the video. So, for the first part here, okay, let me pause here. Okay, I repeat the video. For the first part here, you can see a neutron wants to hit the nucleus of uranium-235. So here is the first part of the equation. Next, when the neutron hits the nucleus, it will produce an unstable uranium-236, which then this fission will release an energy and produce barium-141, krypton-92, and 3 neutrons. This is how fission happens. Now, we are interested to discuss more on this energy. Have you ever wondered how massive this energy is and how we want to calculate the energy? Before we go deeper into EMC squared, let's get to know with AMU. So what is AMU? AMU is a short form for atomic mass unit, where it is a measurement of the mass of an atom. It is hard to measure atom using units such as grams and kilograms. This is because the mass of an atom is too small. Let's explore AMU by using carbon-12 because carbon can be found in many compounds on Earth. First, 1 mole of carbon-12 is equal to 6.023 times 10 to the power of 23 atoms carbon. What is meant by this number? So, this is Avogadro number, right? Avogadro constant, you may say. You've learned this in chemistry. Next, 12 AMU is equal to 12 gram. So what is meant by this? Let's say in a carbon, we have 12 grams. So this is 12 AMU. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we want to know 1 AMU. 1 AMU is equal to how many kilograms? Okay. So, right, what we should do is first, so we want to know 1 AMU. In 1 AMU of carbon, it is 1 over 12. 1 AMU is equal to 1 over 12 of carbon, right? 1 carbon. So, we don't know an atom of carbon, what's the mass? So, in 6.023 atoms, it is equal to 12 gram, right? So how we want to know the value of one carbon? So 1 carbon atom is equal to 12 gram divided by Avogadro constant. So if we put this equation in this, we will get 1 AMU is equal to 1 over 12 times this 12, right? So we can cancel this. We will get 1 AMU is equal to 1 over Avogadro constant, which the answer will be in kilogram is 1.67 times to the power times 10 to the power of negative 27 kilogram. So this is the important value in this topic. Next, we proceed with mass defect and energy. First of all, what is meant by mass defect? So, mass defect is the total mass after fission minus the total mass before fission, or in other words, it is the loss of mass due to nuclear reaction. Alright, you have familiar with this figure, right? This is nuclear fission. So, the total mass before fission here, and this is the total mass after fission here, there is a slight difference. There is a mass loss in this reaction. So how we want to find the mass defect? So the mass defect is the mass after fission minus the mass after fission minus the mass before fission. And you will get the mass defect here. We already know what is mass defect. Now we want to know what is meant by energy. Energy is the energy released due to nuclear reaction. So, what is the relationship between energy and mass defect? Yes, you are right. The relationship is this magnificent equation, which is E equal to mc squared. What is meant by this equation? So E is the total energy released, while m is the mass defect, and c is the speed of light in vacuum, and the unit for this equation is, since it is energy, the unit is in joule or kilogram, like this. Okay? Alright, we already know the relationship between energy released and mass defect. Now, we want to know the energy released in a nuclear reaction. So, how we want to know the energy? Okay, first, from this figure, we have the mass defect. How we get the mass defect? Again, this is the mass after fission. Okay, the total mass after fission, and this is the total mass before fission. This before fission, right? Okay, next, we plug in the value in the formula. So, here we want to find E, right? So, the mass here is in AMU. Okay, can you see? I put it here. So, I want to convert it into kilogram. So, 1 AMU is equal to this kilogram. So, this is mass. And then, we times it with the speed of light here with square root. Don't forget the square. Okay, next. So, you will get, if you put the numbers into the calculator, you will get this value. And not to forget, the units for energy is joules. One extra information is, nuclear energy can be expressed in the unit of mega electron volts, MeV, where 1 MeV is equal to 1.6 times 10 to the power of negative 13 joules. So if you want to get the answer in MeV units, so you just divide the answer here. You just divide the answer here into with 1.6. Alright? So you will get this value, 173.73 mega electron volts. Are you okay? Good. You are great. Let's do some evaluation to check our understanding on this topic. The first question is 1 AMU is equal to, yes, 1.66 times 10 to the power of negative 27 kilogram. You are very good. Next, how to find the mass defect in a nuclear reaction? Yes, to find the mass defect, the total mass after fission minus the total mass before fission. The last question will be, what is the relationship between energy released and mass defect? You're correct. E is equal to mc squared. To conclude, the relationship between energy released during nuclear reaction and mass defect can be summarized with the equation of E equal to mc squared. So, feel free to scan the QR code to fill in the exit ticket before you end this video. I think that's all from me. I hope you enjoyed this video and learned something new. Thank you for watching this video. Hope to see you again in the next video. See you soon!